Hello, dear students. Today we are going to talk about the philosophy of science. Philosophy of science is a section of philosophy that explores the essence and structure of science, its dynamics, role, and place in the life of a person and society. Our lecture outline has 3 sections. In the first section, we will discuss science as a cultural phenomenon. In the second, we will talk about basic dimensions of science in modern philosophy. We will speak about science as a system of knowledge. In the third section, we will talk about science as an activity. And the last section of our lecture, it would be talking about science as a social institution. Science is a multidimensional phenomenon, and this fact was realized by philosophers quite recently, in the last century. Therefore, science today is studied in several aspects, dimensions, and the philosophy of science gives a generalized, integral picture of this complex phenomenon. The main task of philosophy of science is to give a generalized idea of science, its development, place in social life, and its connections with practice. At the same time, it reveals the internal structure of this complex phenomenon, reveals the general and special theoretical constructions, studies methodological approaches and methods, all of its cognitive tools. Philosophy of science is a branch of philosophy that explores science in all its dimensions, as a socio-cultural phenomenon, as a social institution, as a scientific and cognitive activity, and as a system of knowledge. Let's talk about science as a cultural phenomenon. Science in the modern world. Active comprehension of the problems of science is one of the most important features of modern philosophy. Already 2 centuries have passed since a special direction of research was formed within the framework of philosophy, and the subject of which was science. The rapid development of science in the last century has caused an active need in society for understanding its socio-cultural functions and opening anthropological perspectives in the context of scientific and industrial revolutions. The transition to the fourth industrial revolution associated with global technologization and digitalization, which is awaiting humanity in the foreseeable future, where scientific results will discover and possibly create new phases of life reality, makes one think about the special status of science in the modern world, about its essence as such. Philosophers could not leave such a challenge unanswered, as evidenced by the emergence in the last century of the philosophy of science already as an independent philosophical discipline that studies the nature of science, its key problem, and analyzes its role in social development. If the main goal of science is to achieve the truth about the objective world, then the philosophy of science is one of the most important areas for the intellectual culture of the application of the intellectual resources of mankind, within which the question is posed and solved, how it's possible to achieve the truth. So, the enormous influence of science on the lives of people makes the philosophers pay attention to science itself and make it the subject of special study. What is science? How is scientific knowledge different from ordinary knowledge? How to distinguish science from philosophy, myth, or religious belief? What is the value of science? What laws does it follow? How does it affect society, culture? How does it affect civilization? What methods so scientists use? Attempts to find answers to this and a lot of other questions related to understanding science as a special sphere of human activity led to the emergence of the philosophy of science, which was formed in the 20th century at the junction of three areas: science itself, its history, and philosophy. Science as a part of a culture. A part of a culture functions in the system of forms of social consciousness and the corresponding types of activity and methods of mastering the world. Possessing internal specifics, having its own subject and ways of reflecting the world, having arisen at a certain time on the basis of the urgent needs of society, in each historical epoch it had its own status and played a certain role in the development of culture and civilization. Today, this status has become decisive for civilization progress, and the role has acquired a leading character in influencing all spheres of society and forms of spiritual development of the world. It is difficult to overestimate the degree of influence of science on the life of modern society. In modern conditions of growth and independence of social processes, science interacts with politics, morality, religion, ethics, philosophy, etc. For example, despite the fact that science and morality are not directly related, represent different spheres of social consciousness, and have different sources, scientific activity is often faced with the need to take into account the moral consequences of its results. This is clearly seen in the example of biotechnology, and in particular genetic engineering and cloning, where the constitution and transformation of the nature of living things takes place. Ethical regulations are especially necessary for this kind of scientific activity. The value narrowly of science, expressed in the objectivity of its subject and results, makes the development of a science-specific ethical code of a scientist especially urgent, because his moral moralities have no less, if not more, impact on the subsequent development of human consciousness and science itself in general. Let's talk about the origins of the philosophical understanding of science. Science, as one of the greatest inventions of mankind, is an extremely complex and multidimensional phenomenon. This is why today it is constantly and thoroughly studied from different angles. In other words, in the dynamics of social development, science itself as a cultural phenomenon is gradually becoming the subject of scientific research. The first attempts to analyze science not from the inside but from the outside, as an independent social cultural phenomenon which has its own subject specificity and clear boundaries, date back to the era of antiquity and are associated with the activities of the ancient Greek philosopher Aristotle. Aristotle sought to systematize the knowledge accumulated by mankind and carried out the first classification of sciences on the basis of logic. Through the development and application of the logical method, he managed to organize the entire totality of philosophical and scientific knowledge. Based on it, Aristotle identified three areas of knowledge: theoretical. This type of knowledge gives knowledge for the sake of knowledge. Practical type, knowledge for the sake of action. And poetic or productive knowledge. It's knowledge for the sake of creativity. In the Aristotelian classification, only theoretical knowledge is actually called scientific, since only the correspond of the main goal of scientific activity, knowledge for the sake of knowledge, the search for truth for the sake of truth itself. The other two groups of knowledge are not scientific: productive or poetic, and practical. They are not scientific knowledge. Aristotle divided theoretical or scientific knowledge proper into three groups in accordance with their subject. The first philosophy, later called metaphysics, is the science of higher principles and the first causes of everything that exists. and accessible to the senses of comprehended speculatively. It's metaphysics. Mathematics, which studies quantitative definites and continuity, in which the objective world is reflected. Here we are talking about the essential properties of things abstracted by the mind. Here at mathematics. And physics, or natural philosophy, which studies various states of bodies in nature. Logic was not included by Aristotle as an independent element in the classification of sciences, but was part of mathematics. He served as the organon of any cognitive process, the doctrine of the forms of thinking with which, according to the philosopher, any scientist should be familiar. The philosophy classifies ethics, politics, and economics as practical knowledge, ethics, politics, and also economics, and aesthetics and rhetoric as poetic or productive knowledges. Since the time of Aristotle, there have been quite a few similar, in modern terms, separate research scientific projects in philosophy. This project was from the Western classics of philosophy: Francis Bacon, Immanuel Kant, Georg Hegel, Auguste Comte, Friedrich Engels, Windelband, Heinrich Rickert, here it is, Heinrich Rickert, William Dilthey, before the domestic ones, Vernadsky, and our contemporaries, Kedrov and Stupin. The emergence of the sciences about science should be attributed to a specific period, the middle of the 19th century, associated with the completion of the process of differentiation of scientific knowledge, separation into independent subject methodological spheres of mathematical, natural science, social, humanitarian, and technical knowledge. A new branch of scientific knowledge, which studies itself, is emerging: science of science. Disciplinary organized structures of reflective comprehension of science as a cultural phenomenon appear. We are talking about such disciplines of science as scientometrics, history of science, philosophy of science, methodology of science, sociology of science, economics of science, psychology of science. These disciplines have one common subject, the science, and the study from specific cognitive positions, research goals, and objectives. The essence of the science, the subject and key problems of modern philosophy of science. Philosophy of science is a branch of philosophy that explores science from all sides of its multidimensional essence, as a cultural phenomenon and a form of social consciousness, as a productive force of society and a social institution, as a system of knowledge and specific scientific and cognitive activity. The object of interest of modern philosophy of science is the study of science in the following problems: revealing the essence and structure of science, demarcation or separation of science and non-science. It's about criteria of scientific character. Defining the social role of science. Analysis of the genesis and dynamics of science, patterns of development of science, its methods, principles, and foundations. Characteristics of scientific and technological progress, scientific and technological revolution, their social effects and prospects. And the status of the science in the development of civilization. In this regard, in modern philosophy of science, it is customary to consider science from the perspective of such subject fields as epistemology of science. It studies the nature and structure of scientific knowledge. Methodology of science. It examines its forms and the methodological tools of science, reveals the structure of science as a cognitive activity. And anthropology and ethics of science. Its branch analyzes science as a social cultural phenomena in the system of social values and norms. The main stage of the formation of conceptions of philosophy of science. The content of the philosophy of science is heterogeneous in the sense that various theoretical constructs are tested in it in the process of reflection on such a complex phenomena. But at the same time, the philosophy of science retains its integrity due to its focus on a very specific subject area. Therefore, it occupies a special place among such areas of philosophical knowledge as philosophy of history, philosophy of culture, and other disciplines. The philosophy of science has historically evolved as a set of various philosophical concepts that comprehend science as a special holistic phenomena. These include empirism and rationalism, relativism, evolutionary epistemology, phenomenological and transcendental philosophy of science, and a number of others: social constructivism, deconstructivism, psychoanalytic theory, structuralism, and others. Over time, a certain problematic field of research has developed its own conceptual apparatus, a set of methodological approaches and research methods. The development of science itself, on the one hand, provides new material for philosophical comprehension, and on the other hand, the philosophy of science returns to it in a reflexive, generalized form, the strategy for development. And this process is continuous and endless as long as human civilization will exist. Therefore, the content of the philosophy of science will be enriched with new philosophical discoveries. If at all the initial stage of its development attention was focused on the logical and methodological aspects of scientific knowledge, on the analysis of the structure of scientific theories, its functions, laws, verification procedures, then at present the area of research interest of philosophers and scientists themselves is expanding and includes questions of understanding science as a socio-cultural phenomena created by people. Therefore, the subject of study of the philosophy of science in the activity of a scientist in the production of scientific knowledge in specific social-cultural conditions. As an independent discipline, philosophy of science began to take shape by the middle of the 19th century, thanks to the works of Mill, Helmholtz, Herschel, Comte, Mach, Spencer, and many others. The term philosophy of science itself first appeared in the work of Turing, Logic and Philosophy of Science, in 1878 in Leipzig. The pioneers of the philosophy of science in Russia include Vernadsky, Berg, Ivanovsky, Rainev, and others. It is obvious that the emergence of the philosophy of science was due to the increased role of science in the life of society and, as a consequence, the growth of the status of a scientist. What is the main stage of development of the philosophy of science? The first stage is the second half of the 19th century, the study of physiological problems and inductive logical procedures of experimental knowledge. The second stage, the first third of the 20th century, comprehension of revolutionary discoveries in the field of physics, mathematics, and cosmology. The third stage, it is the second third of the 20th century. It was the attempts to create an exact language of science. It was the language of science on the third stage. And the fourth stage, modern stage, an appeal to the problems of culture and historical dynamics of scientific knowledge, its role in society, relations with other forms of culture, its contemporary stage. What are the main philosophy of science conceptions? The various conceptions of the philosophy of science have offered their own vision of the development of science. There was a need, and in fact it persists to this day, for a philosophical generalization of the regularities of the development of scientific knowledge and its system as a whole. Their constituent elements were the philosophical and ideological, theoretical, methodological, and logical assumptions adhered to the philosophers or accepted by scientists themselves. Historical is the first concept for the development of scientific knowledge, were internalism, externalism, and dialectical concepts. Concept and dialectical conceptions. Internalism there are three main areas of internalism: empiricism, theorism, and hypothetical deductivism. The representatives of these areas of knowledge you can see here. And following types of externalism you can see here: economic, social, psychological, philosophical, and cultural, with their representatives. And the dialectical concepts increased about by Einstein, Born, Planck, as well as philosophers of science, our contemporary philosophers, domestic Stopin, Gaidenka, and many others. By now, some principles of synergetic as self-organization in systems of a very different nature are being added to the standard model of the development of science. An example of such self-organization are various virtual communities in the internet and in general various information arrays. The heuristic potential of the mentioned concepts is far from being exhausted. On the other hand, they allow us to comprehend modern science in its various dimensions and the relative completeness of the problematic, and on the other hand, they offer methodological tools for specific scientific research. This applies primarily to the standard model and its expanded and supplemented format. Its potential has not yet been exhausted, but philosophical curiosity is trying to comprehend the scientific frontier, post-non-classical science in the postmodern world. Let's speak about the main aspects of the existence of science. Due to multidimensionality and complexity of the nature of science, as philosophers talk about, it is rather difficult to give it an ambiguous and complete definition from a philosophical point of view. Moreover, science, like any other element of culture, has a specific mode of existence in society, largely determined by the characteristics of the latter. For example, the rudiments of science that originated in antiquity are completely different from medieval prescience, and even more so to the classical science of the new and modern times. The development of a complex concept of science took quite a long time, despite the fact that its main features were quite well and intensively manifested in history, and the closer to our time, the more distinct. The most common general definition of science today is following. Science is a sphere of human activity, the function of which is to develop and systematize reliable knowledge about natural, social, and spiritual reality. In this definition, three most important dimensions of science are formulated, corresponding to the subject fields we have listed, reflecting independent lines of research in modern philosophy of science. Let us dwell on the characteristics of the main aspects of the existence of science, which we will designate as the main dimensions of science. So, today philosophers distinguish three main dimensions of science. Science as a system of knowledge, science as an activity, and science as a social institution. Let's consider each of them in more detail below. Now we are going to talk about science as a system of knowledge. Specificity of scientific knowledge. In the modern era, humanity is on the verge of the post-industrial revolution, which reflects the latest results of the scientific and technological development of civilization. Awareness of this obvious circumstance prompts us to think that no other sphere of culture has had such a significant impact on society as science, both in our worldview and everyday reality, we are everywhere dealing with the consequence of its development. We are accustomed to most of them, if not to say fused. There we are no longer inclined to notice them, or even more to see them as special achievements. The rates of its own growth and transformations of science, the effective and comprehensive application of its results in practice in the field of technology are reflected in the change of technological structures. We are gradually entering the sixth technostructure, which is characterized by the active use of cellular and nanotechnology, digitalization and automation of production, and according to Foucault, will lead to a sharp decrease in energy and material consumption of production, to the ability to design materials and organisms with predetermined properties. We are moving towards Industry 4.0. Science has opened such and many other perspectives of mankind. The modern level of the quality of life of society is largely based on the use of scientific achievements. Today, science not only transforms the sphere of production, but also influences many other aspects of human activity. Science is multifaceted, but above all, it's the production of knowledge. The main aim of the science as the system of knowledge is production of knowledges. It is the production of knowledge that makes science a science. Knowledge production is directly related to cognition. Cognition is such a reflection of reality by a person, the purpose of which is to obtain reliable knowledge about the world. It is a spiritual reproduction of reality. Objects, phenomena, processes, and their properties and relationships in the form of knowledge. The production of scientific knowledge is the main result of scientific knowledge. Scientific knowledge is a process of obtaining new objective, true knowledge about reality, reflecting the laws of nature, society, thinking and cognition of the surrounding world. In scientific knowledge, a special attitude towards the world is reproduced, informational and cognitive, or more broadly, rational and theoretical. Scientific knowledge theoretically comprehends the world in the form of universal conceptual schemes, reveals causal relationships, deep laws that underline it. Ideally, scientific knowledge is a reproduction of reality as it exists independently of a person and his cognitive activity, as it really is in its own characteristics. So, the essence of scientific knowledge is rationality. Scientific rationality is characterized by the so-called conceptual creativity, work with idealized objects. For example, a material point, an ideal gas, an idealized object. This object focusing on the cognitive activity of consciousness, on the work of reason. Scientific rationality focusing not on emotions, passions, and personal opinions, but only on consciousness and the work of mind, of intelligence. Like other forms of cognition, science is a social historical activity, and not just pure knowledge. Therefore, when clarifying the nature of scientific knowledge, it is important to pay attention to the things that characterize it as a process, the special, highly specialized and professionally organized activity aimed at obtaining new objective, systemized, substantiated knowledge about nature, man, and society. Any activity, and even more so scientific and cognitive, is a purposeful, procedural, structured activity. In production, a lot depends on its tools, and a breakthrough in this area leads to major transformations in society. The same is true for science. Modern society is already unthinkable without information technology, without the use of high-precision technology and other results of scientific and technological development. In scientific activity, the invention of the telescope and microscope led to a significant breakthrough. The society of the future, and in the short term, in the inconceivable without high technologies, without digital technologies, artificial intelligence, without BICS convergence. The development of robotics and automation, digital technologies, artificial intelligence systems, global information networks, integrated high-speed transport systems, clean energy, according to scientists for cost, opens up the possibility of a rapid transition to the fourth industrial revolution, the sixth technological order, to Industry 4.0 at the global level. The results of scientific knowledge as a special activity are scientific facts, empirical generalizations, scientific hypotheses and theories. This, figuratively speaking, is the product of scientific activity. Scientific facts are objective processes, indefinite and appropriately expressed based on a specialized language. They are the basis for empirical generalization that combine numerous scientific facts into a specific system of knowledge. Scientific facts and empirical generalizations form the basis of science, and such forms of knowledge and new ideas and hypotheses are also important. They are called search engines. Sometimes without them it is impossible to make a scientific discovery, to get new knowledge, organized into a scientific theory. The idea of a quantum by Max Planck, the principle of complementarity by Bohr, and the principles of uncertainty by Heisenberg were the heuristic ideas and hypotheses that made it possible to create quantum mechanics. The structure of scientific cognition includes three levels of cognitive activity of the subject of cognition. The empirical level, or observational discourse, in the process of direct interaction of the subject of cognition with the object of cognition. The main task of cognitive activity at this level is the collection and systematizing of facts. Empirical level. The main aim is the systematizing of facts. The main form of scientific knowledge is scientific fact on this level. Here we have, at the empirical level, we have scientific fact. The theoretical level, theoretical discourse, reflexive, is the level of revealing internal, essential connections and patterns of scientific facts. The main forms of scientific knowledge at this level of cognitive activity are problem, hypothesis, law, and theory. Theoretical discourse, theoretical level of knowledge produces problems, hypotheses, laws, and theories. And metatheoretical level, or metatheoretical discourse, is the level of methodological activity of the subject of cognition, the level of operating the subject of cognition with methods and cognition methodology. Okay, metatheoretical level produces methods of cognition. Specific features of scientific knowledge are usually called the criteria of scientific character. These include the following characteristics: objectivity, focus on achieving objective truth about reality; essential character, focus on discovering objective laws reflecting the general, essential properties of objects, fixed in a special scientific language, in the system of abstraction, in the form of idealized objects. Some formulas are idealized objects. Consistency, systematization of knowledge based on theoretical principles, collection of facts, their description and generalization is brought to the level of their inclusion in the system of concepts in the theory. Conscious and controlled use of special means and of cognition, artificial language, for example, mathematical symbols, chemical formulas, methods, for example, an experiment. Instruments, scientific equipment, for example, radio, telescope, microscope, etc. Strict evidence, the next characteristic of scientific knowledge. Validity of the results obtained, reliability of conclusions. And the next feature is anticipation of the future with the aim of further practical mastery of reality. In the modern methodology of science, such criteria of scientific character are also distinguished as the formal consistency of knowledge, experimental verifiability, reproducibility, openness to criticism, freedom from bias, rigor, etc. Scientific knowledge, like all forms of spiritual production, is necessary in order to regulate human activity. In the modern era, the era of unprecedented success in scientific and technological development, this is gaining spatial relevance. Of course, science does not set itself the task of developing social regulators. For this, there are other forms of spiritual production and culture, philosophy, religion, and other. But the modern science, having long become one of the leading institutions of civilization, plays an important role in shaping the images of the future of humanity, the prospects and forms of our future existence. One of these prospects is Industry 4.0, which will have in fact an anthropocentric nature, meaning the massive introduction of cyber physical systems in the production and service of human needs, including the professional, household and leisure spheres. In this regard, the importance of studying the specifics of science as one of the main subjects of innovations in the implementing fourth industrial revolution from within its structure, including the cognitive one, is extremely increasing today. Let's talk about the structure of scientific knowledge. The view of science as a system of knowledge was primary in the history of intellectual culture and dominated in knowledge and practice until the 19th century. Science as a system of knowledge is a collection of ordered and substantive information about natural, social, and spiritual reality. In the most general sense, knowledge is understood as a set of judgments about reality which differ in the degree of generality and reliability of the conclusions obtained. In science, knowledge is knowledge based on rationality. Usually, the following things of scientific knowledge are distinguished: objectivity, inambiguity, accuracy, certainty, consistency, logical evidence, verifiability, validity, or empirical or theoretical, and instrumental utility. Also, scientific knowledge is characterized by objectivity and universality, reproducibility of results, the desire to eliminate errors, overcome contradictions and development. The body of scientific knowledge is characterized by the conceptual form of its expression, accessibility for criticism, orientation towards truth, a tendency towards systematic coherence and consistency. Science as a system of knowledge is characterized by the interconnection of all its consistent elements, concepts, hypotheses, laws, theories, facts, etc. The structure of scientific knowledge as a system consists of three levels: empirical or observational, theoretical or reflective, and metatheoretical. They all differ in subject matter, functions, and methods. The empirical or observational level includes empirical data and facts, generalizations, and patterns. The theoretical level is presented by concepts, categories, laws, principles, hypotheses, and theories. And the metatheoretical level is a level of premise knowledge, the elements of which are the scientific picture of the world, the ideas and norms of science, the philosophical foundations of the science. Empirical or observational knowledge is the lowest level of rational knowledge. It is a set of statements about empirical and abstract objects obtained through mental or rational processing of the results of observations and experiments and recorded using certain linguistic means. Single observation sentences, graphs, natural classifications, etc. So, the subject of the empirical or observational knowledge is empirical and abstract objects. An empirical object is a real, natural or social object that has a certain set of features that are recorded in the process of scientific observation or experiment. An abstract object is a result of abstraction of empirical objects. It is a rationally presented object of scientific knowledge which represents certain essential characteristics, properties or relationships of things and phenomena of the surrounding world. Abstraction is a way of replacing the observed object with a mental construct, abstract object. Destruction in the process of cognition from non-essential aspects, properties, and connection of an object in order to highlight its essential characteristics. At the empirical level, there is a direct contact of the researcher with reality. That's why it's called observational discourse, in which scientific facts are established through observation and experiment. This level of science fixes the higher properties of the studied objects and processes, their relationships, and on this basis deduces empirical patterns. The structure of the empirical level of knowledge is made up of facts, empirical generalizations of laws. It's called also dependencies. The concept of fact is used in several meanings. First meaning, it's an objective event, a result related to objective reality. It's a fact of reality, or to the sphere of consciousness and cognition, and then that's the fact of consciousness. A second meaning, the fact is a knowledge of any event, phenomena, the reliability of which has been proven, truth. And the third, fact is a sentence that captures knowledge obtained through observations and experiments. An empirical generalization is a system of certain scientific facts. Empirical laws reflect regularity in phenomena, stability in relations between observed phenomena. These laws are not theoretical knowledge. Unlike theoretical laws, which reveal essential connections of reality, empirical laws reflect a more superficial level of dependence. The empirical level of scientific knowledge is characterized by the predominance of sensory cognition, the study of the external world through the senses. Therefore, the main methods here are observation, measurement, and experiment. At this level, the forms of theoretical knowledge are present but have a subordinate meaning. The next level is a theoretical level of scientific knowledge. This level of science is always built on the top of the empirical one. The facts obtained in the empirical level find here their interpretation and explanation. In theory, knowledge acquires a systematic, ordered, hierarchically structured character. Theoretical knowledge is a set of statements about idealized object, the reproduce of mental activity. Theoretical knowledge reflects phenomena and processes from the side of their universal internal connections and patterns, comprehended through rational processing of empirical data. Ideal objects are the subject of theoretical knowledge. Ideal objects can be constructed both on the basis of empirical object using idealization, for example, absolutizing the properties of empirical objects, and introduced by definition, for example, with the help of mathematics. Ideal objects are not observable in principle. A feature of theoretical knowledge is the extremely high degree of its logical organization, the evidence of most of the statements. The structure components of the theoretical knowledge are the problem, hypothesis, and the theory. A problem is a complex theoretical or practical problem, the solution to which are known or incompletely known. A hypothesis is an assumption that requires verification and proof about a cause that causes a certain effect, but the structure of the objects under study and the nature of the internal and external connections of structural elements. A scientific hypothesis has the following characteristic properties. First, relevance to the facts of which it relies. Second, testability empirically, comparability with observational and experimental data, with the exception of an unverifiable hypothesis. Third, compatibility with existing scientific knowledge. 4. Hypothesis must have explanatory power. A certain number of facts and consequences confirming it must be derived from it. And the fifth, simplicity. The hypothesis should not contain any arbitrary assumptions, subjectivist layers. Theory is a logically organized knowledge, a conceptual system of knowledge that adequately and holistically reflects a certain area of reality. The theoretical level of scientific knowledge is characterized by the predominance of logical methods of cognition. For example, mental experiment, ideal modeling, formalization, idealization, etc. At this level, the obtained facts are investigated, proceeded with the help of logical concepts, inferences, laws, and other forms of thinking. Here, the objects under study are analyzed and generalized. Their essence, internal connections, laws of development are comprehended. At this level, cognition with the help of the senses may be present, but it is subordinate. The empirical and theoretical levels of scientific knowledge interact, which is as follows. A set of facts constitutes the practical basis of a theory or hypothesis. 2. Facts can support a theory or disprove it. A scientific fact is always permitted with theory, since it cannot be formulated without a system of concepts, interpreted without theoretical concepts. Empirical research in modern science is predetermined, guided by theory. Empirical knowledge discovering new data stimulates the development of the theoretical knowledge, set new tasks for it. In theoretical knowledge, the focus is on the development of improvement and development of the conceptual apparatus, work with conceptual systems and models. Such activity opens up new perspectives for explaining and predicating facts, variably its orientations, and directs empirical knowledge. The concept of the structure of scientific knowledge that has developed in modern philosophy is no longer reduced to a simple empirical and theoretical dichotomy, but presupposes the presence of the highest level of scientific knowledge, metatheoretical. Metatheoretical knowledge is a set of statements that constitute the foundations of scientific theories, axioms, principles, a scientific picture of the world, ideals and norms of science, and philosophical generalizations. Due to the systematic nature of scientific knowledge, metatheoretical knowledge directly refers to fundamental scientific theories. For example, in mathematics to arithmetic and geometry, in physics to mechanics, in biology to the theory of evolution and genetics, etc. The structure of metatheoretical knowledge is: we have some dimensions in the structure of metatheoretical knowledge. The first dimension is scientific picture of the world, general scientific picture and special scientific picture. The next level is the ideals and norms of science, ideas and norms of science, the ethics of the science. As the next level is the philosophical foundations of the science. Scientific picture of the world, SVP, a set of general concepts of science of a certain historical period about the fundamental laws of the structure and development of objective reality, a subsystem of meta-scientific knowledge, which is one of the most important elements of the foundations of the science. A private scientific picture of the world, a set of ideas about the world prevailing in any science, mechanical, quantum, electromagnetic, thermal, etc. The general scientific picture of the world is, as a rule, one of the particular scientific pictures of the world which is dominant in the science of a particular era. For example, the hypothesis of the Big Bang, the expanded universe, the theory of evolution, etc. Scientific ideals and norms, SIN, is a set of conceptual, methodological, and value attitudes that ensure the organization and regulation of the process of scientific cognition. For example, the intrinsic value of truth, the value of novelty, the falsification and plagiarism of scientific activity, etc. And philosophical foundation of science, PFC, initial philosophical principles, ideas, and categories that set cognitive guidelines for science and ensure the inclusion of scientific knowledge in culture. For example, the principle of cognoscibility, determinism, consistency, observability, and given the essence in the phenomena, idealism, substantialism, atomism, etc. The subject of metatheoretical knowledge is scientific theories and their various elements, and the tasks of metatheoretical knowledge are logical analysis, general scientific and philosophical substantiation. Therefore, this level of scientific knowledge is characterized by the use of logical methods of cognition, the main of which here is the principle of reflection. Metatheoretical knowledge is the highest level in the structure of scientific knowledge. Its main function is to test specific scientific theories for their compliance with the standards accepted in the scientific community, analyze them, substantiate and criticize them for the standpoint of metatheoretical knowledge. The role of significance of metatheoretical knowledge in science is especially in demand during periods of scientific revolutions or in a situation of choice among competing theories and research programs. In science, there are no certain unified and generally accepted in the scientific community of its foundations. There are different types of philosophical foundations of science in terms of content: ontological, epistemological, social, axiological, and anthropological. Their choice in each specific case can be different and is determined by three main factors: the content of scientific theories, the philosophical preferences of their creators, and the attitude of the scientific community. Now we are going to talk about science as an activity. Specificity of scientific activity. The foundations for understanding science as an activity were laid in classical German philosophy. Immanuel Kant and his followers played a special role in this process. The philosopher emphasized the creative nature of scientific activity. Indeed, scientific activity is a cognitive activity aimed at obtaining new knowledge. Science as a specific activity is a system of cognitive actions aimed at producing reliable knowledge about natural, social, and spiritual reality and cognition itself. So science is not only a system of objective knowledge, but also a specific activity. In the Marxist tradition, it was customary to call scientific activity one of the types of spiritual production. If we accept this interpretation, then it is necessary to understand what kind of product science produces. Products, or in modern terms, the results of scientific activities include, first of all, scientific knowledge and methods. We can say that in the course of scientific activity, in a certain sense of the word, its subject itself is created, professionally trained specialists with special knowledge and skills. But it is important for philosophy to identify fundamental characteristics of the knowledge. From a philosophical point of view, the fundamental result of scientific activity is a theoretical and cognitive attitude to the world. Science develops a special way of orienting a person in the world, a rational theoretical one. Science as an activity differs from other types of human activity by the production and reproduction of special relationships to the world, which consists in revealing and underlying objective laws of nature and is expressed in the form of universal conceptual schemes. Thus, scientific activity is, first of all, cognitive activity associated with the production and reproduction of objective knowledge, methods, and cognition, and special cognitive attitude towards the world. In addition to purely cognitive activity, scientific activity includes other types of activity. For example, innovative activity. It's introduction of accumulated knowledge, technologies, and equipment. Engineering and technical support of scientific research. Creation of an experimental base for science. Organization and management of science. Development of scientific and scientific technical policy. And creation of an effective network of scientific communications for information exchange within the scientific community and outside it between science and society as a whole. What is the structure of scientific activity? Science as a cognitive activity has a strictly defined structure. The subject of scientific activity, the object of scientific activity, the means and methods of scientific activity or tools, and the results of scientific activity. The subject of scientific activity is one who carries out scientific activity. It is customary to understand the subject of scientific activity not only as an individual scientist, but also research teams, the scientific community as a whole. The subject of science realizes its main goal as a cognitive activity. It produces objectively true knowledge about the world, reveals the objective reasons and laws of reality. The object of scientific activity is a part of reality that is investigated by the subject of scientific activity. Science seeks to know the whole world in its diversity. But in the real practice of science as a cognitive activity, the subject of scientific activity deals with a certain area, a separate part of reality. As a rule, it reflects the subject of science, the representative of which is the subject. As the practice of scientific activity shows, there is a sphere of the unknown, and every scientist is aware of this. Moreover, as scientific knowledge grows, this area, on the contrary, is expanding. Since the scientific results obtained give rise to more and more complex questions and problems that creates new objects of science. The object of scientific activity becomes such only as a result of the active material, practical, and theoretical activity of the researcher, of the subject of activity. A fragment of reality, having become an object of cognition, is the first of all subjected to objective tool influence. For example, in the course of an experiment and in order to become an object of theoretical thinking, it is converted into an ideal object by presenting it through the prism of scientific concepts, a specially created system of scientific abstractions. The subject of scientific activity is the characteristics and patterns that the subject of scientific activity explores in the object of scientific activity. Therefore, the object of scientific activity in terms of its volume and content is much broader than the subject. We can say that an object is certain integrity, and an object is an part of this integrity. The concept of subject of science captures the things of the object of knowledge necessary for its cognition in the course of the active cognitive activity of the subject. The means and methods, or the tools, of scientific activity are specific instruments of scientific activity. The means of scientific activity are divided into material, for example, special devices, installations, and other scientific equipment; informational, for example, computer technology, information technology, telecommunications; and formal logical, mathematical and logical laws. Also, there is linguistic means of scientific activity as one of the tools. For example, a specific scientific language containing rules for constructing definitions or concepts. Methodology of scientific activity. Let's speak about methodology. The most important tool of scientific and cognitive activity is the method. The main function of the method is the internal organization and regulation of the process of cognition or practical transformation of an object. Therefore, the method is one of the form or another is reduced to a set of certain rules, techniques, methods, norms of knowledge and action. The method of cognition is an artificially constructed system of rules and operations, conditioned by the objective properties of the subject and object of cognition. The method itself is not contained in the object of knowledge. They are the techniques and operations developed by the subject for obtaining new knowledge, conditioned by the laws and properties of the object. The subject, following his cognitive goals, can achieve them only by developing operations and procedures that are adequate to the characteristic of the object. Thus, in its most general form, the method can be defined as a system of regularity principles, rules, and techniques of theoretical and practical activity, developed by the subject on the basis of the object under study. The methods of scientific activity are a set of specific principles, rules, and techniques for obtaining, checking, substantiating, and building scientific knowledge. Methods occupy a special place in the structure of scientific activity. Their development determines the level of development of scientific problems, as well as the real possibilities and prospects of science in the analysis of natural and social phenomena. That is why the methodological tools of science need permanent attention, both by scientists themselves and by philosophers of science and methodologists. Let's talk about empirical cognition methods. The main methods of empirical cognition, characterized by the predominance of sensory cognition, include observation, measurement, experiment, description, and comparison. Methods of the theoretical level of knowledge are: these methods are based on rational knowledge and logical inference procedures. These methods include General logical methods are abstraction, analysis and synthesis, analogy, induction and deduction, modeling, generalization, comparison, axiomatic method. Theoretical knowledge requires its own methods of cognition, focused on testing hypotheses, substantiating principles, building a theory. The most important methods of theoretical knowledge are axiomatic, climbing from the abstract to the concrete; hypothetical deductive method, the method of the unity of the historical and the logical; idealization; systematic and structural functional analysis; and formalization. General philosophical methods also belong to the theoretical level. Philosophical methods are the system of principles, operations, techniques that have a general universal character. They are not described in strict terms of logic and experiment, do not lend themselves to formalization and mathematization. The key ones are analytical, hermeneutic, dialectical, integral, metaphysical, phenomenological, semiotical, etc. The metatheoretical level of cognition is the highest level of cognition, at which the self-reflection of science, its self-knowledge and reflective comprehension take place. A clear classification and description of the methods of metatheoretical cognition does not yet exist. Nevertheless, certain lines in the structuring of the methods of metatheoretical cognition have already been outlined. These include: first, the constructions of method theories; second, development of concepts of understanding as a functional assessment of theories in accordance with the ideals and norms of research accepted in the scientific community; third, philosophical interpretation of theories, for example, identifying or attributing certain philosophical grounds to them; and the fourth, expert assessment and forecast of the practical applicability of certain scientific theories; and the fifth, a philosophical assessment of the ideological and general cultural significance of the theory. The results of scientific activity at the empirical level are scientific facts, empirical generalization, and empirical laws. And the results of the theoretical level are scientific problems, hypotheses, and theories. Scientific facts are objective processes indefinite and appropriately expressed in scientific language. An empirical generalization is a system of certain scientific facts. Empirical laws reflect regularity in phenomena, stability in relations between observed phenomena. A scientific problem is a problem as a complex theoretical or practical problem, or a complex of them, the ways of solving which within the framework of a given science are unknown or not fully known. A scientific hypothesis is an informed assumption about significant dependencies in the study of the object of knowledge, acting as a form of knowledge development. Theory is a logically organized, conceptual system of knowledge that adequately and holistically reflects a certain area of reality. The results of scientific knowledge at the level of method theory are the scientific picture of the world, the ideals and norms of science, and the philosophical foundations of science. And at last, let's talk about organizational forms of scientific activity. Science as an activity is organized according to the disciplinary principle, with the allocation of scientific disciplines, mathematics, physics, sociology, psychology, etc., within which any cognitive actions are consistent with the characteristics of the objects and subjects of research, as well as the specifics of the required knowledge and scope of its application. There are also such forms of organizations of scientific activity as the field of research, where some characteristics of related disciplines are combined, and program-targeted research aimed at solving complex problems. Creation of new materials, space exploration, for example, the world's oceans, and new energy sources exploration, etc. Since, as an activity for the production and systematization of knowledge, is represented by some groups of sciences. Natural sciences, the sciences about nature. Social and humanitarian, about society and people, about human. Technical or engineering knowledges, sciences, give the knowledge about artificial objects. And formal sciences, that tells about cognition and thinking. For example, logics and theory of cognition. Vladimir Vernadsky wrote about science as an activity. Such words. Science content is not limited to scientific theories, hypotheses, models, the picture of the world they create. At the core, it mainly consists of scientific facts and their empirical generalization. And the main living content is it contains the scientific work of living people. Here we turn to the characterization of science as a social phenomenon. Next we will talk about people in science. Now we will talk about science as a social institution. Science as a social phenomenon. At its core, science is a social phenomenon. This means that it originated in society, depends on the processes operating in it, determines its target priorities in the social context, and itself largely determines social life. Science arose in response to a certain need of mankind in the production and receipt of true, adequate knowledge about the world, and exists having a very noticeable impact on the development of all spheres of social life. This influence began to acquire a civilizational scale from the 17th century, when science acquired the status of a factor in the development of European civilization. For this, people wrote one of the philosophers of the contemporary philosopher Ortega Gasset about the first scientists of the modern European civilization. The idea of science was the basis on which all human problems were built and ordered. Therefore, moral and political issues from them were easily resolved by referring to a simple requirement prescribing to society and the state such an organization in which nothing can hinder the progress of sciences. It was the words by Ortega and Gasset. In modern philosophy, the boundaries of understanding science are expanded to the boundaries of culture. Science claims to be the most important foundation of the latter in its activity and technological understanding. As a social-cultural phenomenon, science relies on the cultural traditions that have developed in society, on values and norms. Cognitive activity is woven into the existence of culture. The approach to science as a social institution was established in the second half of the 20th century, when the sociology of science and the number of other disciplines of science were formed. The American sociologist of science Robert Merton is considered the founder of the institutional approach to science. However, the collective nature of science was already realized by Aristotle, Bacon, and many other philosophers, and we have talked about it also. Science is the result of the activity and interaction of many minds. It involves the organization of research activities using various forms and methods of communication. What is the specifics of the institutional design of science? Science is a social institution, is a community. As a social institution is a community of people engaged in scientific activities, organized by a system of scientific institutions. In this dimension, science includes not only the system of knowledge and specific activity, but also the system of relation between scientists, scientific organizations, and countries, and their interactions. The number of the modern scientific community is about 5 million people in the world. The institutionality of science presupposes the formalization of all types of relations within the framework of scientific activity and presupposes, first, the creation of various organizational forms of science, its internal differentiation and specialization. The second, formation of a system of values and norms that regulate the activities of scientists, ensuring their integration and cooperation. And the third, the integration of science into the culture and social system of society and the state and the world. So, thinking about science, philosophers of the past understood that it has a social character, but this understanding had only an abstract character and did not receive real expression in the research practice itself. If, as we have already said, the study of science as a social institution became an independent field of research relatively recently, then science itself took shape as a social institution in the new time in Europe. Until this moment, scientists conducted their research work separately and did not represent the scientific community. The institutionalization of science outwardly looked like an association of scientists at universities in departments, and their self-organization in academies, laboratories, and later in research institutes. It meant a kind of social self-regulation of science and assumed the formalization of relation between scientists, their integration into stable social structures and institutions with established rules and established norms. Scientists have gradually integrated into a single scientific community. In Europe, the first scientific communities were the Royal Society of London in 1660, Paris Academy of Science, Berlin Academy of Sciences, Petersburg Academy of Sciences, as well as new associations of scientists, French Conservatory, Collection, Assembly of German Naturalists, British Association of the Promotion of Progress, etc. You can hear all the organizations here. In the 19th century, the organizational structure of science was supplemented by research laboratories at large universities, on the basis of which research institutes of a specialized nature were later created. As a result, the sphere of scientific activity acquired a ramified structure and now includes 3 main sectors. The first sector is academic science. It is organized mainly in the form of a system of research institutes integrated into national and sectoral, agriculture, medical, technical, etc., academies of sciences. Their activities are managed by academicians and bureaus of specialized research institutes. University science is represented by research institutes of large universities and also by separate structural units, more often laboratories. Management is carried out by rectors of universities. And the next sector is industrial science. This sector is represented by research institutes of different profiles and sectors of the economy, education, healthcare, culture, defense, etc. At present, non-traditional forms of organizing scientific activity are also functioning, uniting scientists from various branches and sectors of science and representatives of various spheres of society in general, scientific centers, foundations, schools, etc. The structure and activities of the scientific community are regulated by regulatory documents and the staffing table of scientific institutions. Members of the scientific community are employees of various sectors of science, employees of academias and research institutes, employees of laboratories, university teachers, graduate students, applicants, doctoral students, and undergraduates conducting research works. The scientific community uses specific forms of communication. Its main forms are official discussion at meetings of departments, academic councils of universities, councils of research institutes, etc. Public discussion at scientific events, for example at conferences, symposia, congresses, etc. And work on a specific topic, including co-authorship and mentoring, for example, professional training of scientists through the system of magistracy, postgraduate studies, and doctoral studies. The most common types of scientific communication are discussion, from Latin discussion, its consideration, a kind of dialogue or dispute aimed at finding a solution to a problem by putting forward a position and critical discussion of different points of view. In science, discussion is a way of discussing and resolving controversial research issues. The second type is dialogue. From Greek, it's conversation, for example, between two persons. It's a specific form of communication involving an oral or written exchange of statements, remarks, questions, and answers between two or more people. In science, dialogue is an exchange of information on a discussed research topic. And the next type of scientific communication is dispute. Dispute is a form of dialogue aimed at argued defense by each of its participants of their own point of view and convincing the opposing side of its truth. The ancient Greek philosopher Socrates argued that it is a dispute that truth is born. Dispute is an important type of communication in science, a factor in its development. Modern philosophers of science argue, for example, about what are the factors in the development of science when it was born, whether or not there are unobservable objects postulated by scientific theories, and about many other things. Initially, scientists argued personally, later in correspondence, and with the appearances of the first scientific journals in 19th century, disputes as well as discussions began to unfold in the form of publications on the pages of scientific editions. Any science has a publication system, the key elements of which you can see here. The first element of this system is scientific article, a completed work or of authorship describing the results of an original scientific research or consideration of previously published scientific articles related to a common topic. The second element is monograph, a scientific work, a work of authorship in the form of a book within an in-depth study of one of the several closer related topic in a science theme. It's monograph. Reviews of publication contained information about the main direction of research work and key approaches to its implementation in a particular area. It's reviews of publications. And the last element is educational literature. It reflects a systematic presentation of specific disciplines of training specialists in a particular field. The presence of the communication system itself in science, its various forms and authorships itself is the most important condition for the consolidation of the scientific community, the growth of professional interaction between its participants, and the development of science as a social institution in general. Science as a social institution is characterized by the functioning of scientific societies, institutions, scientific periodicals, scientific conferences, discussions, science links with other social institutions. In the scientific community, it's often referred to as big science versus small sciences. that developed prior to the institutionalization process. And the last ethical standard is disinterestedness, as a principle that determines that reward for scientific work should not be an end in itself for a scientist, but act as a condition for productive work. Today, science as a social phenomenon includes numerous relationships with various spheres of society: economy, politics, culture, and others. Responding to the economic needs of society, science realizes itself in the function of a direct productive force, acting as the most important factor in technological development. In response to the ideological needs of society, science appears as an instrument of politics. Science as a social institution functions, maintaining a connection with the power and ideological structures. Science as a social institution is penetrating ever deeper into business and politics. Scientific activity exerting a growing influence on education, morality, religion, and legal regulation. The process of replacing traditional low technologies with high ones, which began in the last century within the framework of the scientific and technological revolution, has led to the emergence of science-intensive industries in the field, for example, of biotechnologies, nanotechnologies, genetic engineering, space, and other technologies. Scientific knowledge is rapidly expanding its worldview meaning. The social development of the 20th century was largely determined by the rapid dynamics of science and the growth of the technosphere associated with it, which became a tangible result of the scientific and technological progress of the modern technogenic civilization. Today, big science is directly related to production and the life of society, and is an effective means of solving various social and economic problems. It relies on NBI's convergent technologies and opens up the prospects of a new technological revolution, which is the main trend of civilizational development. Thus, the social functions of science continue to expand, and this fact is of undoubted interest both for scientists and philosophers, and for everyone who is interested in the future of mankind. Okay, at the conclusions, we have to admit that science plays a special role in modern civilization. The application of scientific results has contributed to the significant technological progress of the last centuries. Modern scientific and technological development prepares society for the transition to the fourth industrial revolution, enter into the sixth technological order associated with the new living conditions. Science creates revolutionary change not only in the sphere of production, but has a decisive influence on many other areas of human activity, starting to regulate them, rebuilding their means and their methods. In this regard, the importance of philosophical reflection on science obviously will only increase in the future. And this research is the main task of philosophy of the science. In this lecture, we have studied the subject and problem field of philosophy of science. We have revealed its origins and defined the main stage of development, concurrent with its main representatives and their concepts, have examined science in three interrelated dimensions: science as a system of knowledge, science as an activity, and science as a social institution. Thank you very much for your attention.